Predict the hybridization of the following molecules using the AX method. So in this one, I'm going to go really fast and I will not draw any Lewis structures because technically speaking, you're supposed to know the Lewis structure. And if you need to do a review on that, see my previous videos. But otherwise, here we're going to go really fast, okay, with this. So PCl3, that's the first molecule that we have. So it means that we have a central atom and then we have 3 atoms attached to it. That much we know. What we need to find out is if the central atom has any electrons left over or not. So phosphorus is in group number 5. Group number 5 means 5 electrons. 3 of them are bonded with chlorine, which means that we do have 1 electron pair left over. So if this is going to be AX3E1, 3 plus 1 means that this is going to be a tetrahedral kind of electronic geometry. If this is tetrahedral electronic geometry, then the hybridization on this one is going to be sp3, and that's it. Okay, there is no other way to do this really quickly using the AX method. Okay, so hopefully as we go on, things will get better for you. So now for the next one, which is sulfur dioxide, I know I have a central atom. I know I have 2 atoms over here. I need to figure out if I have any lone pair of electrons left over. So sulfur, which is supposed to have 6 electrons in the valence shell because group number 6. But then it has only 2 electrons left over because 4 electrons are bonded with oxygen. So how is it that 4 are bonded with oxygen? Is because I know that oxygen requires 2 electrons, okay, for it to share in order to have an octet. So which means that you have E1 left, okay? So really quick, this is what the Lewis structure would look like, okay? So you have 1 electron pair left over, and so this is AX2E1. So that is 2 plus 1, that's a 3. So if it's 3, that means that I need 3 orbitals. Okay, so if I need 3 orbitals, it means this is going to be sp2. So s is 1 and then 2 for p, that's 3 orbitals, okay, in there. So that's how the sp hybridization works for SO2. Let's look at the next one, which is CO and then 2. So carbon has 4 electrons, 2 which is sharing with oxygen and 2 that is sharing with hydrogen. Okay, so which means no electrons are left over. So it means that the formula is AX3. The formula is AX3. I have 3 electron groups. 3 electron groups means that I need 3 orbitals. So which means sp2, 1 from s, 2 from p. H2SO4. So H2SO4 is a little complicated. So we've done the Lewis structure of H2SO4 before, and it is something like this. Okay, so I will draw this one out because we do need to see the Lewis structure in order to see how many different kinds of central atoms we have in this one. So sulfur is one central atom, and then we have oxygen also as another central atom, which means that we are going to have at least 2 AX formulas. Okay, so for sulfur, it's going to be AX4, all right, because it has 4 electron groups around it. For oxygen, it's going to be AX2E2 because the X2 is coming from the 2 atoms that are attached to it, and the E2 coming from the 2 electron pairs that are left over, okay, from the non-bonding electrons. So we have 2 different kinds of AX formulas, and I hope you agree with me that both of the oxygens are the same, okay, here. So both of them are going to be then AX2E2, okay. So both of them have a tetrahedral electronic geometry. So tetrahedral electronic geometry, because this is 4 and this is 2 plus 2. So tetrahedral electronic geometry means that I need 4 electron groups, and I can get the 4 electron groups from sp3. Okay, so that's 1 from s and 3 from p. That will give me the 4 electron groups. I hope I'm not going too fast for you, but if you're comfortable with your Lewis structures and if you're comfortable with AX formulas, then this is really the quickest way to figure out the hybridizations. Let's look at the next one, which is CCl4, and CCl4 carbon is in group number 4, 4 electrons. So this one is pretty simple and straightforward because you will have AX4 here as your AX formula. So if it is AX4, it means that the hybridization is sp3 because you need 4 electron groups. Okay, so the total of sp3 is 4 orbitals. Okay, so BCl3 now, BCl3 is going to be AX3 at least, and boron is in group number 3, so it doesn't have any electrons left over, so which means this is it. Okay, AX2 is, AX3 is it, and if this is it, then it means that you have sp2 hybridization, okay, in this case. So that's how all of these things will work out. Now let's just take one on the fly over here and see how that one will work out. So if we take something like HCN, so in case of HCN, you have one bond with carbon and hydrogen, and then a triple bond with nitrogen. That's 2 electron groups that you have. So if you have 2 electron groups, that's AX2, and that's going to be then sp. So the sp is actually coming from the X, not from the central. Okay, however, the hybridization is for the central atom. Okay, but the X2 is telling you how many orbitals you need. All right, that's how I'm working this.